Okay, your final 4 enrichment questions from volume. The first question says true or false. The surface area of this particular cube is larger than its volume in terms of number. So the surface area of a cube, since one face of the cube is side squared and there are 6 faces, if I was to make the net, we would be able to see it better. The formula for the surface area of a cube is 6 squares. The formula for the volume of a cube is side squared multiplied by its height. So the first thing you had to be able to do is differentiate between what does surface area mean and what does volume mean. So there are 6 faces, each of which is 64 meters squared. If I multiply that out, I get 360 plus another 24, which is 384. I would have a surface area, and the units are important, a surface area of 384 meters squared. Its volume, however, would be 8 squared multiplied by 8, or 64 multiplied by 8. And right here, to get its surface area, I multiplied 64 by 6. To get its volume, I'm going to multiply 64 by 8. Without even knowing what the number is, I know that this has to be larger than its surface area. So therefore, the answer would be false. The volume is a larger number than its surface area. Question. Okay. So the answer is the volume is bigger. The second question, it says this liquid in this container is $5.50 per 100 mils. How much would this particular thing cost? The first thing I'm going to do is calculate the volume of the full container if it were full. This would be 3 multiplied by the radius, which is 10 squared, multiplied by the height, which is 20. This would be 300 multiplied by 20, which would be 6,000 centimeters cubed, or 6,000 milliliters. Since it is 60% full, 60% is 6/10 of his multiplication, 6,000. I would get 3,600 centimeters cubed, or if we're talking about liquid, 3,600 milliliters of liquid. So what I wanted you to do, and it didn't say explicitly to do it this way, but what I was hoping you would do is set it up as a proportion. So $5.50 for 100 milliliters is equal to, I don't know how much, for 3,600 milliliters. Okay? Now there are 3 ways you can solve it. We already talked about this before. If you can determine your multiplier, in this case I know it's 3.6, I could do it this way, and I would get my answer. If you didn't know that, you could break it down to a unit rate, meaning I could divide it by 100 and get how much it costs for 1 milliliter, and then multiply it by 3,600 to get the cost for 3,600. Or, one more spot, there we go. Or the one method that I was hoping you would use, because when we studied proportional reasoning, a lot of you preferred this method, was to use an algebraic method. So multiply across there, you get 100x. Multiply across this way, you get $5.50 multiplied by 3,600. That would be 19,800. Divide both sides by 100. I don't need a calculator for this, because when I divide by 100, I just move my decimal 2 places over. And x would equal 198 bucks. Okay, so $198 would go here, right? So it's $5.50 for 100. If it's proportional, it would be $198 for 3,600. Okay. Your next question gives you this particular drawing and says this is what is full in this particular aquarium or whatever it happens to be. You add that particular amount of liquid to the container. Will it overflow? Again, same as before, you're going to calculate the full volume. So the area of the base, since it's a rectangle, will be this, multiplied by the height of the whole prism, which is that. 30 times 25 is 750, multiplied by 10. The full volume of the aquarium is 7,500 cubic centimeters. It's only 80% full, so I'm actually going to calculate 80% of it by doing that. Grab my calculator. Full aquarium is this. 80% of it is that, which means 80% of the aquarium, there is 6,000 cubic centimeters of liquid, or since 1 cubic centimeter is a milliliter, there is 6,000 milliliters in that aquarium. This particular container, we can quantify that, or we can figure out what that is as a number. The volume in that container, since it's a cylinder, would be this formula. 3 multiplied by, since the diameter is 10, the radius is 5. That will be 75 times 15. Take my calculator. The volume of liquid in that cylinder is 1,125 milliliters, or cubic centimeters. If I add that on to the amount of liquid in there, add that on to what's currently in there, I get 7,125 milliliters. We already know that the full capacity of that aquarium is 7,500. So the question is, will it overflow? No, it will not, because the current volume is 7,125. Okay? So the answer is no, it will not. And the last question, which was the dumb question, it was a brain fart on my part, but you know what? I'm just going to do the answer real quick. The answer was, what's the smallest cube? It's a 20 by 20 by 20, because a 20 by 20 by 20 is exactly 8,000 cubic centimeters of space, which is what this would be. So the answer is that. And what percent's available? 0% available. But through the powers and miracle of YouTube, I'm going to change this question right now. And I'm going to change this number to 9 liters. And I want you all to do it now. Okay, so here's your hint. If we made a 30 by 30 by 30 cube, that volume would be 27,000, centimeters cubed, which is too big. And in the previous one, we knew that 20 by 20 by 20 was 8,000 cubic centimeters, which was not enough. So if we figure out what number multiplied by itself is 9,000, we can actually use our calculator. I have a scientific calculator. And remember we said before that there was a magical button on here called the cube root button right here. And that's going to tell me what number multiplied by itself gives you 9,000, 3 times. And the answer is 20.8. So if I had a 20.8 by 20.8 by 20.8 cube, 20.8 by 20.8 by 20.8 cube, it would approximately have a volume of 9,000 milliliters. But we said you can't have a decimal. So what's the smallest cube you can have? 21. Your distance has to be 21 by 21 by 21. And if we had that as our cube, 21 times 21, the area of the base would be that, multiplied by 21. The volume that this cube could hold would be 9,261 centimeters cubed, or 9,261 milliliters. Okay? Is everyone with me so far? Now, the question is, what percent is available? So the full amount of that cube is what part of your fraction? The full. What do we always associate with the total in terms of fractions? Our denominator is always how many we have in total. So in this case, our denominator is our total amount, which is 9261. That's the maximum capacity of that cube. The amount we have is 9,000. So 9,000 out of 9261, we can consider that to be a fraction. And we can change that fraction to a decimal by dividing the numerator by the denominator. And we get 0.9718, which is approximately 97%, which is approximately, therefore, approximately 3% is available, right? What percent's available? If it's 97% full, approximately 3% is available for more liquid. Does that make sense? Okay.